Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, today we'll discuss one more question on JEE Advanced 2014 Physics Paper 1 question number 7. So let us start with question number 7. Students, let us solve question number 7. The question says heater of an electric kettle is made up of a wire of length L and diameter T. So there is a kettle which is made up of a wire of length L. So suppose this is the wire which is whose length is L and its diameter is D. It takes 4 minutes, so it takes time T equals to 4 minutes to raise the temperature of 0.5 kg, half kg of water by 40 Kelvin. So it takes half kg, it takes 4 minutes to raise the temperature by 40 Kelvin. And what is the amount of water? Half kg. This heater is replaced by a new heater having, so this is the situation, first situation. The other situation is this heater is replaced by another heater. So let me use another color for this. This is another heater having two wires. So in this case we have got two wires of same material. Material is same, but each of length L and diameter 2D. That means diameter is double, something like that. Length is same, so length will be L, diameter will be 2D. And how many such wires? There are two wires. So there are two wires like so, each of length L, diameter 2D. So instead of this, if we use these two wires, then how much time it will take? Says these, the way these wires are connected is given in options. How? Wires are in parallel, wires are in series. So these two wires are connected in series and as well as in parallel. This is the situation. Series and parallel. How much time in minutes will it take to raise the temperature of same amount of water by 40 Kelvin? That means earlier whatever time it was taking, that was 4 minutes for half kg of water to raise its temperature by 40 Kelvin. In this arrangement, if these two are in series, how much time it will take? And if they are connected in parallel, how much time it will take to increase the temperature of the water of half kg by 40 Kelvin. So how much time it will take? That we will find out and see which of these options is or are correct. So what will be the change in these arrangements? So first of all, we'll have a basic equation of heat and that is produced by this wire. We know that by Joule's law of heating, we know that heat produced is I square RT. It is also written as B square by RT. Now, if I talk about this equation, because the potential difference that we are supplying in all those arrangements are same, so I'll use this equation. Heat can be written as M S delta T Delta T is the rise in temperature, S is a specific heat of the substance here, that is obviously water, and M is the mass of the water. That is equal to V square by R into T, this small t, this one. This in the first case, when one wire is used, only one wire, whose length is L and diameter is D, we have a time t equals to 4 minutes that is given to us. This is 4 minutes. So this equation, if I apply, this is the general equation. If I apply this equation to this case, I will have this left hand side is same, because this has to be if I put everything whatever is that, then that is I call as heat produced. That heat produced is same in both all these arrangements, including the first one. So this H is same for all. So for here also, whatever heat it has produced will be V square by R into T. And now V square by R, R is resistance of this wire. So that will be only change the resistance. Resistance of the wire is rho L upon A. A is upon A is pi d square by 4. Pi d square by 4. So this way, if I simplify, I will have V square by rho L, and this divided by this will be here divided by, so this will come up, pi d square will come up here, and 4 will be there. So I will write something like this. I'll just simplify this. You can see here that resistance part I will consider. You can see that resistance is so many quantities are there. So I will just simplify that. First of all, you find the resistance of the wire with the formula rho L by A. A is pi d square by 4. So this is the situation. So this situation I will directly divide here. So it will be rho L 4 and pi d square will come up. Okay. So that was B square by rho L was there. And now it will be, I'll just write here, H will become V square by T. T is there. I have not written T. T is there. V square T divided by the resistance, and the resistance comes out with this. That is equal to rho L 4 pi d square. In this situation, we see that everything is same, and here t is 8 minutes, 4 minutes given in the question. So this is v square by rho L 4 pi d square into t is 4 minutes. 4 minutes. This I write this way. So this is my H, or I will say H1, whatever is that, the first case. So better I will write H1. So what I am getting, H1 equals to V square pi d square by 4L rho and 4 minutes. This is the situation number 1, when only one wire is used of length L and diameter D, and this is the situation. Now we have two options, series and parallel combinations of the two wires. Next we'll consider the second case 1 with those two wires having diameter 2D, length D. In first we'll consider in series, plus this of length L and 2D in series. So we have this and this, and if I consider the So if I consider these two in series, then I don't know what is the resistance. Obviously I'll say the resistance here is suppose R1, here is also resistance R1. Each of these will have resistance. R1 is rho L by A is pi d square by 4, d square is 4 d square by 4. So if I consider the earlier resistance was the earlier resistance and this resistance, there is a difference because the resistance is inversely proportional to d square. So in this case the diameter is doubled, everything is same, diameter is doubled. So if this is doubled, the resistance will be 1/4. So this is basically is R by 4. R by 4, that means I will write this as rho L. And this is basically this is your R. Okay, what is R? R was rho L 4 divided by pi d square. So therefore I took R by 4. This is also R by 4. This resistance will also become R by 4. But when they are in series, R equivalent will be R1 plus R1, that is 2R by 4, that is R by 2. So in series, if these conductors are in series, the total resistance will become R by 2. If the resistance is R by 2, then if I look at the option here, this equation of heat produced, then I'll write H2 in this case, that H2 is equal to H1, the heat produced is same, but here it is V square by R1, R equivalent in this case, into time T, obviously T1, I'll say something else that I'll take, and because the left and right side is same, so I'll have this in the left hand side, this value I'll put it here now. So V square pi d square divided by 4 L rho into 4 minutes. This is my H1, because in both the cases we have to produce same heat, but right side how much time it will take depending on the resistance. The V square is same, the resistance R equivalent is rho L by A. So rho L by A is rho L by A right here, pi d square by 4. So it is pi R equivalent, I could have written R by 2 also. Okay, L by, I will write this, instead of this I will write directly from here, I will write V square by R by 2. This is R equivalent, which is R by 2 into T1. You can write directly like this. Now R you can write again as rho L by A, that is pi d square by 4, and this 2T1 is there. So this I have written and 2T1 is written. You can see that this V square pi d square, V square pi d square, 4L rho are both sides, they will cancel out, and this 2 will cancel out. So you'll have 4 minutes in this side will be equal to 2T1 on the right side. So from here T1 equals to 2 minutes. That means when instead of a single conductor so in place of a single conductor, if I take two conductors in series having same length but diameter doubled, then the time taken will be 2 minutes. That means it will take half the minutes to solve the question. So if I see the options, if I see the option, then you can see that 2 minutes, how much time in minutes? 2 minutes. If two wires are in series, this answer is correct. in series 2 minutes. In series 1 minute is wrong. So this is right, this is wrong. Next we have to check the parallel. Out of this, which one is correct? So let us solve for parallel connection of these two wires. Now if I go for case 2, that means these two wires are in parallel connection, and length L and diameter is 2d, and we have already known that the resistance is rho L by A. Here rho L by A is pi d square by 4. So resistance is inversely proportional to d square. As diameter doubled, R will become R by doubled. So 2 square 4 R by 4. So its resistance is R by 4 and its resistance is R by 4. And they are in parallel. So when the resistance are in parallel, we have R equivalent will be product by sum. So this will cancel out and this is R upon 8. So now the resistance, equivalent resistance of this combination will be this, and heat is produced according to the resistances. Here the resistances is reduced by 8 times. So if I write the equation that the same amount of heat is required and how much time it will take, V square by R equivalent into time t, suppose T2 time it will take, then I see that for R equivalent being reduced to R upon 8, if I write R upon 8, this will become V square by R upon 8 T2 H. And this H was nothing but earlier H, which was V square by R, comparison to this, that was V square by R, and the time was 4 minutes in the first case. So compared to the first case, V square by R 4, here we are getting V square by R 8 times T2. V square by R will cancel out, and from here we have 4 equals to 8 T2. From here T2 equals to 0.5 minutes. That means if I connect those conductors in parallel, it will take half minutes to raise the temperature of that amount of water, that is half kg of water by 40 Kelvin. So if I see the option, then half minutes, 0.5 minutes we are getting in parallel connection, and in 0.5 minutes is here if the wires are in parallel. So this is correct. 4 minutes is wrong. This is correct and this is correct. So option number 2 and 4 are correct. Okay, so this is the answer to this question. Option number 2 and 4 are correct. Okay, thank you.